Okay, so now we're going to rotate an object around the origin. Remember that an origin, first of all, is at 0, 0, and counterclockwise would be a rotation this way. Clockwise would be the other direction. We don't see many analog clocks nowadays, but this is how we think of it. So clockwise means you're going to be making a rotation this direction. Counterclockwise is the other direction. So if we're going to be rotating counterclockwise around the origin, here we have this rectangle and we need to take it, and you need to picture taking this whole image and just rotating it over here. So if you can vision or do some kind of picturing with your brain, what this rectangle would look like if you rotated it. Instead of being vertical, it's now going to be horizontal. But it's easier if you think about this as point to point. So where U is here, you see this makes like a little box here. So if you were to take that box and you were to rotate it, like stick that origin where it is, and just move your rectangle over here, you notice that your U is going to move from here down to there. Same thing with your T. You see your rectangle here. It's at -2, -9, where that T is. If I were to make this a big rectangle and I were to rotate it, you notice that the T would come over here. So instead of being at -9, it's going to be over here 9 and be down a couple. Let's just take a look at what they did. Again, we're looking at a one. So 90 degrees is 1/4 of a turn. Notice that they are illustrating that here. Let's say an 880 degree turn would be all the way down here. So in this case, we're just going 90. So what they did is they're explaining this by using boxes again. Where is S? S is down here at -6, -9. Now we're going to take it and rotate it counterclockwise. So if we picture this box and you rotate it 1/4 of a turn, your S prime ends up down here at 9, -6. Same thing over here. If we look at our T, our here, what we're going to do is we rotate it, again, picturing this box, it ends up at 9, -2. All right, so let's do a couple here. Now we want to graph the image of RST after a rotation of 180. So 180, this triangle isn't going to just move over here, it's going to move all the way down to here. And now we're going to take it and we're going to kind of almost flip it over the other direction. Again, we picture a box here with the R at the 3, 6. Now we're going to come over here to -3, -6. And now we just have to create that image so it's kind of say we got 4 spots down there. So that would be that image if we took it and moved it. Actually, this would be more accurate, so that the T is pointed down here. So you took it and you rotated it all the way around. Okay. Now this is 270 counterclockwise. So 270, we're not going to go to here. That would be 90. This would be 180. 270 is going to be all the way around here. So we picture this box again. So this box for N would take us to here. And then we go one more time, it would come up here. And then we come one more time, and it's going to be down here. And then you can see where the K is. We just have to go 3 spots over. And the M is going to be, it looks like, about 6 spots down. And then the L is going to be 3 spots over. So that should be it being rotated 270 degrees counterclockwise. All right. So if you have any questions, please let me know.